One last video in this section that you may find helpful is that Wolfram Alpha is utilized, or can be utilized, excuse me, to be able to ensure that our solutions to our Laplace transforms as well as the inverse Laplace transforms are correct. And let me show you how easy this is to check some of these. So for instance, I can just find the Laplace transform. And you might remember that we did one of this example earlier in the guided notes of something like t squared or 4t squared minus 5 sine of 3t. And then we can just go ahead and execute that. I just hit enter. And there it is right there. All right. So now, of course, you want to make sure that you know how to do that for yourself for the examination, and also to make sure you do it step by step on the assignments. However, this doesn't hurt at all to make sure that you've actually gotten the answers correct. All right. They do have a couple of the alternate forms, which may be helpful to be able to try to combine the like terms of these sorts of things. So that's pretty cool. You can do that. Even with like the first translation theorem, you might remember we had something like this one, not just something like this one, but we had e to the 5t times 6 to the t. And then we divided all of the, or t to the 6, excuse me, t to the 6, and then we divided all of that by 720. All right? And we actually got a pretty clean answer for that. So let me go ahead and execute that. And if we execute this, we get 1 over s minus 5 to the 7th power. All right, and you might remember that that was what we got before when we did this. All right, so hopefully that's a good indicator as to how to try to work these types of problems with Laplace transforms to check your answer. We can do the same thing with inverse Laplaces, which is even nicer. So you might remember that we had something like this one. So I'm just going to type in inverse Laplace transform of quantity 1 minus s to the 3rd. And we're going to divide that by s to the 4th. And remember, we got 4 terms for this. We had to FOIL this out first, and then we had to go through. All right. And right here, it gives us the form that, it's not necessarily the exact form that we had, but this is one of the forms that we looked at earlier. Okay, so hopefully that helps everybody to see how this works out really nicely to find the inverse Laplace. In fact, just one more example of that. Remember, we just took a look at, in the last video, I believe we had something like 2s plus 5 divided by s squared plus 9s plus 34, and you might remember we had to complete the square, we had to break it up, and we got 3 terms out of that. And one of the answers it gives is this, which is not a nice form. Oh, it was 6s, that's probably why. That might be a little bit nicer. All right, it gives us the complex form, but if you scroll down just a little bit, it'll give you this really nice form. All right, and that's the one that I believe we got the solution to when we figured out what the answer was. Okay, so pretty cool that we can do this. One last thing that I wanted to show you, or a couple last things I wanted to show you with Wolfram Alpha that could be helpful when you're trying to work through your assignment problems, is that Wolfram Alpha can do the partial fraction decomposition and check it for you. Of course, you'll have to show me all the steps that you know how to do it yourself, but we could just say we want partial fractions, and you might remember that we had something like I think it was s over the quantity of s squared plus 4, and we multiplied that by s plus 2. And I think we got like a 1/4, negative 1/4 and a half. We did that. All right. and we have a 1/4, we have a 1/2, and we have a negative 1/4 if we were to split these up, right? So that could be helpful for you to check your solutions when you're doing this for the partial fraction stuff. One last thing I'll show you is that we can utilize, I believe we can use Wolfram Alpha to solve systems. So let's just have a really basic system. So let's solve the system where x plus y is equal to 1, and then we have x minus y is equal to, let's say, 3, right? And that should be a pretty easy system. In fact, I don't even know if we need the brackets on this. And it just goes right here and it solves it. If I wanted to put 3 variables in there, I could say x plus y plus z equals 1, x minus y plus z is 3, and then 2x plus 3y plus 5z is equal to 10. Now this is probably not going to be a nice answer, but just to illustrate that you can solve it. By the way, I totally guessed, and we got some really nice numbers out of this. So just showing that you can use Wolfram Alpha, which is completely free. The syntax is very forgiving to be able to check your solutions. However, of course, we want to make sure that we know how to do all of these things by hand for ourselves, so that way when we move on to our higher level math classes, that we don't necessarily always have to rely on Wolfram Alpha to do all the work for us.